Welcome everyone to another exciting learning session. We still have attendees joining in, so we'll give them a few more seconds to join. So thank you. Wonderful. I think we have a lot of folks joined in, so we can start, Satej. Once again, welcome everyone to another exciting learning session. Satej Sahu, Principal Data Engineer at Zalando SE, has joined us today, and he will be presenting on the topic From Unstructured Docs to Graphic Intelligence, a framework for building graph+embedding pipelines. Over to you, Satej.
Thank you, Pooja. I hope everyone can hear me out. So today, I think I hope everyone is having a wonderful time today at the conference. My topic today is from documents to graph intelligence. So let me start on it. Just a brief disclaimer on that the ideas which are proposed here are entirely mine and don't represent any views of my current and past employers. So to start with this, we understand there are different PDFs, contracts, different documents in the organization, and each of them in a certain context contain a value or knowledge. And at most of this time, this is locked in, and this knowledge is not available for us directly. And this is where we look, I think, in the current scenario of large language model, agentic AI, we look forward to RAG because of its improved groundedness and compared to direct large language model responses, and even in compared to fine tuning in particular. So if anyone has a brief idea, so we are feeding the documents to a vector store, which is indexed in an token format with embeddings. And when a query user queries, there's a vector match which is happening with the vector store with the inclusion of the query being converted to the embeddings, and we do a similarity match based on the simplest algorithm we choose, and we get a few comparative documents or the response back. And this is something which we then share with the large language model along with the query, and we get a response in a human friendly manner. So this is what RAG essentially means here. The question here is, should we always use RAG? Is it the right solution for all the use cases? And from experimentation and use cases and seeing different levels of usage in different contexts, what I feel is there are two things which mess, or there are different variants around how it matches in terms of what we are looking for in the answer. And two particular are the facts and the contextual answers which mess. And these are two levels. One is how do you chunk your data? Because based on the chunking strategy, and as we have seen, with the 2 and 3 years of large language model evolution, there have been different strategies which have come for chunking in particular, with some overlapping and requerying, doing LLM judge, a variety of procedures there with increased contextual awareness. But essentially, the context and the factual kind of also depends on the model which you choose to create your embeddings, because maybe they don't have the understanding of your business domain, because most of the embedding models are generalized data and they might not understand very specialized industries like medical domain, etc., to give you that mapping or the matching. And with that, you also need very super high skilled, uh, I think, network to build you that fine tuned embedding models to give you that more richness in terms of the extraction. And this is the two layers where RAG essentially kind of fails on some levels to give you that exact match, and also in terms of the contextual and kind of the relevance of the answers. So this is also where I think some teams also mm, spend time into the observability or evaluation phases. Now the question comes is the D2G, E framework. So this is kind of a open source framework which I've created, and this relies upon two particular things. Is one is it relies upon embeddings, but at the same time, it also relies upon the knowledge graph. I think knowledge graph is very important in terms of how a particular entity correlates to other entities. And some of you already might have known about knowledge graph, which has been happening, I think, the last 1 or 2 more years. I think this idea has been principally promoted and I think created in I think has its source in Neo4j in particular in terms of how they have explored different paradigms and patterns around more groundedness and including uh, the relationship here. So if you factor in the 4 points here, D to G, I think it's more, it does some of the similar things like it passes the documents, kind of the ingestion. But, and also if you see the fourth step, kind of it also generates the embeddings here. But principally, I think the two other parts where it also focuses upon, if you see, as the entity relationship, which graphs databases are very good at managing or storing them. And we also need something to extract this out. So this is one of the all other core part of this framework where it generates this relationships and stores it. And the fourth and the third part, which you see the knowledge graph. So how do these entities, because you can generate a one entity relationship, but how does it connect overall to other parts too? That's where the knowledge graph comes in, and it also grounds it more into the fact when you ask particular queries to it. So essentially, we saw the problem statement and what we are trying to solve here. And these are some of the, kind of the core or base abstracts of the technology which we can use it. And one is we're using a structured document. We'll go through a demo where we have a test file and we'll go through the content and we see through the flow, as to how it parses the document and the relationships and the graphs about. The structured data can be stored in your FAISS. You can also use for some open source solutions like Pinecone, etc. But here again, hybrid is something which we are relying upon because we want to combine the best of these two, where you're retrieving based not only on semantic because embeddings, but also on the knowledge graph where you're also matching for exact matches. And this gives you the power of both the world with an increased level of matching and groundedness. So now visiting the problem statement, if you see two parts here, one is relying upon the RAG, which is more relevant to the vector search. It captures the semantic similarity and retrieves related passages from your paragraphs and whatever. But it also depends on how do you ingest it, what's your overlap between, and you have to spend a lot of I think time designing those systems, particularly the overlap and all these systems. The challenge with it is the struggles with the exact matches, dates, and names, and we'll see that in an example. And did not have relationship context. While at the same time, when you go to the knowledge graph side, you have explicit entities and relations. And one of the very interesting things which I found with relational uh, kind of databases is that you can do a multi-hop reasoning very easily with the queries being very fast enough with algorithmic progress we have made there. And the only, I think, prerequisites to it is it requires the extraction pipelines where you need, the systems in place which can extract those entities out because that's foundational for building knowledge graphs. And you also need the entity relation based on how do you want to compare. So there are different libraries which can support you. And so to summarize, you have enterprise knowledge which is buried in very different heterogeneous documents. RAG pipelines only use embeddings and they miss the factual details and context here. What we need is more kind of a hybrid approach which combines semantic and symbolic reasoning here, giving an advanced groundedness and the search for the user relevance. So if you see, these are the 6 components which are part of the pipeline, where you have documents, and we are using one of these tools like LangChain and spaCy, which helps us with parsing and chunking. And we are using spaCy also for entity extraction here. Once that is done, we create embeddings, and this embeddings either you can use OpenAI or any open source. And I think I'm relying currently on Olama, which gives me an open source environment here locally. And the storage can be Neo4j plus VectorDB or Neo4j with its embeddings database. And finally, we'll test, how the hybrid query using GraphRAG helps us here. So, because again, when it comes to GraphRAG, it's an advanced version of RAG that uses a knowledge graph along with the relationship, which is pretty interesting. So, essentially, 5 steps. We pass the text. From the text, we extract the triples. Triples basically mean the subject, action, and the object. So, it gives us a relationship. And we encode the passages and nodes in Neo4j and store it there. And finally, we query it using GraphRAG. So going to the parsing and chunking step, these are the 3 steps which we are following. First is we extract the PDFs, and we're using 2 libraries from LangChain, particularly the PDF loader and the unstructured file loader. We'll go to the text file, which helps us to read through it. And we also are doing split the documents here with some overlapping chunks here, basically with 300 and 600 tokens, more or less. And we're also using the spaCy's code reference resolution to mitigate some of the contextual losses here. There's a very simple code which is shown here, which we are loading the libraries from LangChain, and we are then loading it using the PDF loader. And second, if you see, we are loading the docs here to have it in the doc format, and eventually we are splitting it based on the chunking strategy. The second part now is, once you have this document, so you now have passed it. The second effect is we go to the entity and relationship extraction. And here is where we focus on the named entity recognition using spaCy. When you're using spaCy library, there are different base models which can help you. I particularly focused upon the base English model, but it doesn't give you the niche capability which you need when you're working on very capable, or I think distinguished domains like health in particular. So the query we will be trying in this demo would be relevant to the medical domain. I've used a more, I think, very particular medical specific model of PC. We can also use large language model. That's another level where we can to infer the relationship in output triples. And this would leverage LangChain's LLM graph transformer, which is very integrated with the graph system. Now, the third part is define allowed node labels. So there's one of the other factors, because if you are sure about when it comes to spaCy and large language model, they could generate essentially, because it all depends upon how you have restructured your source data, or you filtered out unnecessary contextual elements there. That is where having a filtering layer, or having another LLM judge, having, if you can define what are the entities which are very particular to the domain, that would help to keep it more localized, so as not to introduce the errors which are present in the document to come to the level of your source data from which you'll be using the GraphRAG upon. And on top of that, you could also process to remove any duplicate entities, and those are very similar processes which you would follow on any ingestion level. So if you see the basically a sample code here, where we're using the LLM graph transformer and Neo4j graph. So we're connecting to the large language model using the chat OpenAI. And if you see, we are passing the node properties and the relationship properties here. And we are now converting and generating embeddings out of it, and storing them in the elements here. And this is where we're connecting now to the Neo4j graph database and storing these graph elements. And just a correction, so here we are generating those entities and relationships in particular, and that is being stored in there. The third part, as we saw, is now we have to generate the embeddings and store them, because Neo4j also provides the capability here in terms not only storing the node relationship, but also any contextual embeddings which would be relevant to it in terms of determination. And this is where you can use open source embeddings databases, or you can also leverage Neo4j particularly. And this hybrid approach is very interesting because it merges both the vector similarity, because you have the embeddings, and at the same time you have the relationship stored at the same place. So there can be hybrid approaches here where you combine Neo4j with other structural elements or systems based on the ecosystem of your organization. So these are some, sample models which you could use. In particular, because I think graph embedding, the Neo4j GDS plugin helps you with some of these when you're doing these conversions. But essentially, these other models are what you can use for the conversion to the embeddings. And similarly, you can use open source models. For my particular use case, I've used Gemini 3-4 billion level parameter using Olama, just to make it simple for me. Now, if you see, let's talk about a few minutes here about hybrid retrieval and GraphRAG. Now, hybrid retrieval, as we discussed, combines two different approaches. One is the vector similarity, because we have embeddings here. And the second is now the graph traversal for more accurate results, because relationships are very important. Whenever you have different systems, they're connected in terms of logistics and different other variabilities. Combining these two factors really help you get more contextual, wider scope answers here. So the hybrid retriever normalizes the vector, and you get a full text score for it in terms of the comparison. And the hybrid Cypher retriever traverses the relationships using multiple help queries, because Neo4j makes it pretty simple for you when you want to do recursive queries here. So GraphRAG builds a knowledge graph from documents. It detects the communities and the connections surrounding it, and generates summaries for each particular community, or the context which we are relating to. So this is essentially the pipeline where you have the document, you're doing processing, you're generating the embeddings, and finally you have the graph structure, because that is very important in terms of all the querying which you're doing. So this is on a higher level, whatever the tools which we are using particularly for our experimentation here. And all of this is present in a GitHub repository, which I can share over. It just contains a pipeline, a Docker compose, so you don't need to maintain any dependencies. You then just start off, right? Finally, once we have all the data in Neo4j, we'll compare both of the results very quickly to see how a common or generalized RAG approach compares across to a hybrid approach. We are comparing with embeddings along with knowledge graph to give us that improved richness with a very simple framework. This can be extended, this can be improved upon. So let me just share my screen and show you the different parts to it. Okay, perfect. So if you see, I have a simple Docker compose file here, and I can just show you here. It contains an Olama, it contains resources, and it connects to Neo4j. a very simple arrangement here. So you just connect here, and you have a container which runs, and it connects to Olama on your 4J. And if you see the structure of the pipeline, we have two simple structures here. We have a data folder where you have the file here. We have two files, but I'll show you the example for the sample text. So if you see pipeline data here and sample, it contains a very simple textual formats which relates to the FTA, and it talks about the drug, meaning I hope it's big enough for everyone to see. Let me see if I can increase the size of that. Okay, perfect. I think this should be visible. Okay. So if you see, it talks about the Food and Drug Administration approved the drug called gefapixant for the treatment of chronic cough, and it was developed by Merck and has undergone, so it has some company references that talks about the Food and Drug Administration. So it's, if you can think about it, talks about the medical domain. So now the next step is we have the pipeline which runs through all of these steps, and I've already run them, but towards the end I'll again show you, how it starts so that you can have an understanding of it as to, and we'll also verify if it works when you restart the system. Now, with this happening, we have the data which has been read, and it now is populating in a local Neo4j setup here. Now, let's see if I can run some queries. I hope it works. That should. So here, basically, I want all the records which have been part of it, which have been the chunks, which have been connected. And if you see, I'm trying to search based on text, kind of the document and what is present inside. So it's giving me a preview of the content which has been chunked, the document, and the dimension is 384. Let's make another query here. And these all just have some foundational aspects in terms of whether the query is set up. So we can see the entities which have been passed here. So GFAG, the Food and Drug Administration, so these are some of the entities which have already been passed. And now we will see the relationship. So if you see, these are different entities which are referenced to that chunk ID. And finally, let's see all the matches or relationship which is maintained in your 4J. If you see, this central document, which you can see on the right, which has the embedding and the text, correlates, mentions, these different aspects of it. Kind of a very simple relationship for this demo. But now let's move to the next step. A batch, we are now relevant, we want to query things, right? So let's say we want to find the drug entity and the chunk that mentions it. So with this, we can think about this query here where we are doing, give me all the document which mentions the entity. And Jeff-Franks, and if you can think, this query can be easily created from a large language model when a user queries about, let's say, give me what are the relevant information you have related to Jeff-Franks. And this is where the knowledge graph is very important, because getting that entity, it has already been scratched here. And now you see we have the preview of the document along with the entity associated here. But what about if the user changes the query here? They don't know the name of the name of the drug in particular, but they would be interested in knowing any entities which are of type drug. That gives you a direct relationship here with Jeff-Franks, and you can think about different wide varieties in which you can connect different queries to give you different information in different contexts, in different scenarios, like in different query perspective. And that's where you can play with different large language models as to how they give you these results. And coming to the next query, let's say I want to think about, give me a drug which is associated with FDA, but also helps with chronic cough. So, and if you think about, give me a right relationship in terms of the Gefapix, it didn't give me any other information. And this is all related to a knowledge graph because it keeps it more grounded in terms of, and this essentially also relates to how you do that ingestion and entity relationship. I think that could be crucial here. But you can see the effect here in terms of the fastness of here, in terms as to how do you get the relationship here. Now let's try another query here. So here it says, give me all the documents which have the text called chronic cough, and give me, the drug name. So you get the first reference is gefapixant with other related effects here like Europe, Merck, which are associated with that. Now, this we are thinking about, let's say we want another very particular here. It says, give me all the documents which relate to a drug and are related to FDA, which help with chronic cough. And it gives me a direct name here, which is gefapixant. Very similarly, I very simple created now a RAG structure. So let's see how RAG is more relevant here and how does it compare here. So I just have a test file here. I run Python test.py. It uses a large language model that still relies upon Neo4j as the comparison. So if you see, it is giving you the information the Food and Drug Administration approved the use of drug get gefapixant, kind of correlates this with the percentage of 66 scale, but it doesn't give you that correlated, that very contextual element. It could miss these by some elements or some level, but if you compare those, you would see how valuable it is to get that very contextual factual information with more groundedness. And I hope this framework helps us to improve upon this with this layers, because relying upon large language models only gives you the amount of groundedness to start with, but you can improve upon it with knowledge graphs, hybrid approaches, and others. And I think comparison always helps, as we saw in these queries. So I think I'm towards the end of my session. Uh, I can take any questions, Pooja, if that's fine, or we can take it offline through the chat. And just one more expect, this is about me, I think, for all attendees of Nodes. I think I have a Nodes 20 discount if you want to leverage it. Yeah, that's it.
Satish, we do have a minute, so if you would like to take any questions, feel free to do so. I do see there are a couple on chat.
Okay. So I think I think one answer I can give is how fast is the approach. I think it's very. I think when you compare, go to the relational database along with the embeddings, I think it's very fast enough, and you're getting that contextual effect here. But when you compare the large language model, you have different components. You have to switch the systems a bit here. But the second, I think, when you compare it, the relationships, the algorithms are faster when you compare it directly with that embeddings and getting those information. And again, you have to feed it to another layer here. So I think comparatively, I don't have the numbers here. I can share those, with you later. But I think it gives at least, I think, a 10 to 20% improvement over the, you know, core GraphRAG in terms of the improvement. And I can take the other question through the chat async. I hope this session was helpful to all. Thank you.
Thank you, Satish, for the knowledge share. And thank you to attendees for joining us today. That brings us to the end of this session. A survey has been posted to collect your feedback, so please don't forget to complete it before you leave. Have a great rest of the day. Bye bye.
Thank you, everyone. Bye.